Hello, welcome to my channel. Let's take the second law. We are talking about the laws of logarithm. We did the first law. Let's take the second law, which also says that the logarithm of any base with the argument being u divided by v is the same as the logarithm of u with the same base minus v with the same base. That is what the law is saying. Then what we are doing is that we are trying to prove whether the law is actually what? True. So in this case, we are beginning with the right hand to work to see if we can get the left hand side. So let's assume that the log of u base b equals to what? P. Then let's take the log of u base b equals what? Q. So if we are taking this as P, this as Q, then we can write this from logarithm into indices to mean that B exponent P equals to U. You remember from here, this to this. That gives us the first equation. This becomes B exponent Q equals to U. This becomes the second equation. How do we marry this together? What we are going to do is that we are going to divide equation 1 by equation what? 2. This is V. Let me differentiate it well. Okay. So we are going to divide equation 1 by equation 2, meaning B exponent P divided by B exponent Q will mean the same as U divided by what? V. Dividing the left hand side together, the right hand side word together. And here you can see that we can employ the law of indices. The same base are dividing. So it becomes B, the exponent of P minus Q from the laws of indices. And the whole of this will be equals to U divided by what? V. So what do we do next? Since we are doing logarithm, let's take logarithm of both sides. That will become the log of b p minus q base b. Let's take it to the same base b. So be equals to log u over b, the same word, base. We can also remember the property that says that if you are having this, the base and the base here are the same. You only take the argument. So we can move along with that property. So this is going to mean that P minus Q equals to the logarithm of U over B over V base what? B. Don't forget, here we can also employ the third law. But because we are not up to the third law, that is why I'm using the property we learned in our first episode. So now what do we do? We can see that PQ is still standing in here, which was originally in this form. So whenever I see P, I put in the log of U base B. Whenever I see Q, I put in the log of V base B. I am only representing the left hand side, which equals to the right hand side, UV, the same base B. You see that we have gotten what we have. The left is equal to the right. Simply means that the right is also what? Equals to the left. So if in case we have a quotient, we have to simplify. We have log, the argument is 3 on 27. The base is what? 3. We are assuming that we are going to use the log. So this is going to be written as log 3 base 3. Taking this minus log 27 base 3. But we can see that this is going to be 1. The logarithm of an argument with the same base become 1. Here we can also rewrite this as 3 exponent 3, whereby it will be in this form. The same base, we take the exponent. So I have log 3 base 3, then minus the log of 3 exponent 3 base 3. I believe you can agree with me that this becomes 1 minus, following the property we have, the same base, the same base, we take the exponent 3, and that gives us a negative 2. So for the proof of the second law, when you are dividing, you subtract. Don't forget it is in the same base. If you are multiplying, you are going to add in the first law. All right, thank you for watching. Come back to this page for the third law. Bye-bye.